TESCOM 2020. Pleasure seeing you all again. Hope you've had some interesting discussions from yesterday. John, Gustavo, over to you.
Good morning, everyone. Welcome back for day 2. We're really now going into a variety of speeches from our keynote speakers, and we've got a detailed plan that we're going to cover today. There's some changes in the program which we'd like to just announce. Gustavo, would you like to cover those?
Yeah, good morning, everyone. We moved 3 talks from yesterday because they had some technical issues to today. There's not major disruption because these were added at the end of today's sessions. So session 5, 6, and 8, they do have a new talk at the end, and they will not disrupt the whole flow of the sessions today. So that you know that you can just check these additions on these sessions. These actually are papers that belong to these topics, so they're not foreign to the topic that are discussed. All right.
Perfect. Thank you. Good.
You're sharing your screen.
Yeah, I think, Pavan, you're sharing your screen. Okay, so I guess we'll make a bit of an introduction for our keynote speech this morning. So our first speaker is Malcolm Lee, who is the Group Head of Technology and Innovation at Babcock International. So Malcolm is the Group Head of Technology and Innovation, and he's also looking at 3 core markets, which is defense, nuclear, and emergency services. So Malcolm leads the group's technology and innovation function with responsibility for implementing the group's technology strategy, including the digital transformation of Babcock's asset management services, as well as the development of other technologies that enhances the group's ability to support critical and complex equipment throughout the asset's life cycle. So I guess we're a couple of minutes early, but I would suggest we can give that extra time to Malcolm for his session. So Malcolm, good morning, and we're looking forward to your keynote. Good, we can see you, Malcolm.
Excellent. And we should have the slides on screen as well, John.
Yes, we can see that too. Lovely. Thank you.
Excellent. Fine. Well, I shall crack on then. So, yeah, excellent. I mean, as John said, I'm Group Head of Technology and Innovation at Babcock International, and I'm responsible for the group's technology team. My team ensures that Babcock takes a coordinated approach to the integration of technology and the support we provide to customers across the sectors in which we operate. Having attended the last TES conference that was held at Cranfield a couple of years ago, it is disappointing that we're not able to get together in person this time around, but I'm really pleased that we all seem to be getting increasingly adept at using these virtual conferences and digital technologies. 2020 has indeed become a virtual year for thousands of people. If there's one tangible benefit that has arisen so far out of this strange year, it is how we show how innovative industry can be in a digital environment. For those of us in the engineering sector with responsibility for managing a vast array of complex and critical assets around the world, like Babcock International, it's an opportunity to further explore how we use that technology to unlock value in what we do. What are the benefits? How can digital technologies be used to create a competitive differential? And how should we be integrating them to add value across the asset lifecycle? Over the next half hour or so, I'll attempt to draw out some examples of how a whole life support approach is used to inform the selection and adoption of new technologies and innovations to generate value in the utilised phase of the asset lifecycle. During this presentation, I'm aiming to give you an overview of, first of all, Babcock and the markets in which we operate. Secondly, the critical importance of through-life engineering service principles to the way we manage and support critical and complex assets. Thirdly, the role that technology, especially digital technology, has to play in creating value for these assets. And hopefully, as I do this, I'll be able to weave in a number of examples that bring to life bring these theories and principles to life in the way that Babcock supports our customers. So what does Babcock do? Sorry, 1 second, I'm just having a slight slide issue at this end. We operate in a number of markets, including defence, emergency services and nuclear. We have over 125 years of engineering heritage, and across the markets in which we operate, we are a leading provider of critical, complex engineering services which save lives, support national defence and protect communities. In defence, we are the UK Ministry of Defence's second largest supplier and the largest provider of support. We're involved in many of Defence's major long-term programmes, and we work closely with the Royal Navy, British Army and Royal Air Force. In emergency services, we are the leading provider of aerial firefighting and the leading provider of aerial medical services across Europe. In civil nuclear, we are the UK's leading provider of nuclear engineering and scientific services, and we're involved across the full nuclear life cycle, from new build, support of ongoing operations, through to decommissioning and restoration of facilities and infrastructure. Not only do we do this in the UK, we also operate in a number of international markets, from Europe to Canada and Australasia, employing around 35,000 people in highly skilled roles across the globe. At the core of what we do is supporting owners of high value and long life critical and complex assets. We utilise our deep engineering and support expertise to deliver products and services that save our customers money, help improve productivity and performance of those assets, and ultimately help our customers deliver improved services to their customers and end users. Now, hopefully you'll recognise in what I've said that Through Life Engineering Services, the Through Life Engineering Services approach is absolutely critical to what Babcock does. In Babcock, we don't explicitly use the PAS 280 standard to define our language and approach. However, there are many similarities in our approaches. When we talk about asset management, it is important to consider the whole life cycle of an asset, as well as the supporting infrastructure and the people and operating the asset, or the part of the enterprise. Within Babcock, we tend to reflect the language of the defence sector by talking about the engineering CAD/MID cycle of concept, assessment, manufacture, in-service and ultimately disposal. But as you see here, as well as the CAD/MID cycle that flows through the middle, there are also a number of other critical functions that are essential to the availability of an asset that an enterprise support partner like Babcock can provide. Babcock operates across the whole asset lifecycle and all of the TEDS value streams through develop, prepare, utilise and retire. However, a lot of Babcock effort is focused in the support phase or utilise phase in the PAS 280 parlance, and it's here that I intend to spend the rest of this presentation and share with you some of the ways in which technology is helping us create value for our customers. Now, I'm not a huge fan of saying the pace of technological change today is unprecedented. There have been periods of rapid technological development many times before. However, there are undoubtedly a number of drivers of technology adoption in Through Life Engineering Services. The economic downturn and budgetary pressures that many of us are now experiencing mean customers are seeking greater operational effect and output at reduced cost in order to create room for investment in new capability and capital programs. Changing geopolitical environment is accelerating moves toward the integrated operating concept for defence and broader government customers. And a growing focus on sustainability in the UK and Europe is creating a need for all facets of government activity, including defence, to reduce its carbon footprint. Packaged with those trends, we also see customers' demand for innovation continuing to increase. Rapidly changing operating environments and increasing levels of data and connectivity are focusing customers on the potential for new value to be unlocked through technologies such as advanced analytics. Our collective response to COVID-19 is also driving a significant rethink on a number of topics, including ways of working, supply chain resilience, and it has highlighted the important role that technology may play in solving many challenges. Technology itself is also transforming the nature of the assets we support and the way in which we support them. Synthetic environments are increasingly important tools for delivery of training and also the design, development, manufacture and support of assets. Robotic and autonomous systems can enhance and increase efficiencies in our operations and increasingly operational decision making, challenging some of the fundamental aspects of system design. Approaches to energy generation, storage and use are rapidly evolving to meet the environmental concerns and compliance, as well as opportunities to improve operational efficiency. And lastly, defence and commercial convergence, absolutely key for many of the markets in which we operate. R&D spending in the economy at large is now driven by civilian investment, most profound in multidisciplinary technologies and dual-use technologies such as IT, sensors, robotics, artificial intelligence and materials, where many of the cutting-edge advancements will now be seen in the commercial sector, and those of us that operate in the defence environment need to look at how we can bring those into a defence domain and apply them in innovative ways to create value for our customers. But without doubt, the two most important technology trends continue to be the increasing digitization of equipment, facilities, service delivery, and people by embedding low-cost sensors coupled with enhanced connectivity, and the proliferation of tools and techniques, including artificial intelligence and machine learning, for utilizing existing and new data to generate operational insights. Digital technologies, data, and analytics are the critical enablers across the engineering lifecycle. Now, within Babcock, we call the confluence of these two technologies digitally enabled asset management, and I'll take a little time to highlight how we're using the digital thread and the digital twins to enhance the support we provide across a range of critical and complex assets. Now, first of all, if I use an illustrative example, Babcock Team 31 has been contracted by the UK Ministry of Defence to deliver 5 Type 31 frigates. Babcock has brought together a highly experienced and integrated project team spanning several regions of the UK to meet the challenging Type 31 programme. The programme is the first of its kind to be delivered under the UK's new National Shipbuilding Strategy, and it will re-energise the UK's maritime capability through modern UK ship design and build practices, including the application of digital technologies. In ships, but common with many other complex assets, technological and organisational limitations often fragment and stovepipe different stages of the engineering lifecycle. Addressing these stovepipes by establishing a digital thread that lives and grows with an asset throughout its lifecycle is a critical enabler to maximising value. Establishing a digital thread will enable us to move to greater levels of predictive support, not just in maintenance, but also in the replenishment of supplies and the provision of new equipment to the point of need. The digital thread begins at the earliest stages of concept design and provides a structure on which an asset's journey builds as it progresses through design, test, evaluation, and ultimately in-service operation. The key is to establish a structure, an architecture if you will, that enables data to pass seamlessly from one stage of the life cycle to the next, and from one owner to another. It's increasingly inexcusable for members of an enterprise to create hugely valuable digital filing cabinets and then, in effect, throw away the virtual key, rather than make that information accessible by others in the build and support of an asset. Only with a fully functioning digital thread can we fully exploit the potential of tools and techniques such as artificial intelligence, machine learning, and digital twins. Within Babcock, we're seeking to develop and build digital threads for a number of assets and programs that we support. In the long term, we believe it can offer huge potential in complex programs like the UK's Dreadnought submarine program, but already we have the opportunity to establish a greater prominence of this in the equipment programs such as Type 31. Digital technology is progressing, and the engineering sector will need to be agile enough to adapt. We already have many of the levers to establish a digital thread at modest upfront cost, using the capability that is largely inherent but left latent in modern platforms and existing design tools. If done right, it allows us to deliver a seamless and frictionless digital thread, whatever part of the thread we're operating in. And that requires us collectively, as customers, industry partners, and for today's audience, academia, to critically examine every aspect of how we manage and share data. So you might say to me, where does the digital twin fit in? Well, in short, the digital twin can be thought of as a slice through the digital thread at a specific point in time. This may be looking back down the thread to use past operational performance. It may be at the current point in time to understand current material state of an asset, or it may be by extrapolating the digital thread into the future to inform predictive maintenance, scenario forecasting, and other such uses. The data that enables the establishment of a robust digital thread and a reliable digital twin spans from real-time command and control at the sharp end to reliable and effective information flows and decision support tools that enable the inventory, logistics, and engineering assurance of the support chain. Any prediction is only as accurate as the data that feeds it, and we must therefore continue to harness the advances in connectivity and security to overcome some of the challenges when our people and equipment are deployed on operations. So I did promise that I'd bring this to life with a few examples of where Babcock is using some of the principles of digitally enabled asset management to unlock value for our customers, and also to provide you with some examples of the technologies that enable us to get a better understanding of an asset's material state. First of all, starting at the asset level, warships are complex, expensive, and often extremely long-lived assets. Like many high-value assets, there's always that pressure to keep existing assets running longer than investing capital in their replacements. An example of this is the Royal Navy's Type 23 frigate programme, where Babcock is working with the Navy to extend the operational life of these critical platforms by twice their original design age. In order to meet this challenge, our naval marine business has developed the Athena Intelligent Support Planning Tool, which forms part of the iSupport 360 suite of tools. Athena fuses together a wide range of data sources to enable the overall material state of a ship to be better understood, and also utilizes predictive modeling to provide a view of the likely future performance of the vessel. The analytics focuses on the availability and safety picture of the top 10 critical systems on the warship, and is able to fuse data of current asset condition with planned future maintenance to predict future vessel readiness. From its beginnings, analysing a handful of key systems, the platform has been expanded over time. Recently, this has included the retrofitting of new sensors, as well as trialling novel technologies such as Li-Fi or light-enabled Wi-Fi to enable mobile diagnostics tablets that could enable the Royal Navy maintainer and the Babcock field service engineer to view current and trending sensor data, and also access the broad suite of technical documentation to support effective equipment diagnostics. This solution has been deployed in trial form in partnership with Siemens and their MindSphere tool, and we believe is a first for Li-Fi deployment on a warship. Now, this program represents a significant change in approach for Babcock and a substantial commitment to a new way of working by us, our principal customer, and much of the wider enterprise. It involved production-ready technology retrofitted to an existing business process and environment. Development of the wider iSupport 360 toolset is ongoing and continually seeks to take advantage of new and emerging technologies. We are now working with our customer, the Royal Navy, as well as Siemens and Rolls-Royce, to extend some of this capability to the newly upgraded power generation management system on board the Type 23 frigates. And we're working with the Navy's Nelson project to look at secure connectivity from the platform to enable shore-based visibility in support of these systems. Tools such as Athena demonstrate their value when we're able to modify how we maintain and support the asset. In the warship example, we can help the customer identify the optimal point at which to replace the components, either before the ship sails or if the ship is already deployed, making sure the customer has the spares on board to do that work themselves. Now, having given an example from an in-service example, the same principles of digitally enabled asset management apply to projects still at the concept or design stage, or developers, PAS 280 would say. The data and insights we gain from current in-service assets can be used to develop digital twins that inform decisions much earlier in the life cycle of related assets, shaping our approach to long-term programs for decades to come. In the aerospace sector, as one of the speakers yesterday touched on, the UK's Tempest programme is seeking to use similar digital twin concepts to model all aspects of the aircraft's performance. But slightly closer to home for Babcock, at least, is the Dreadnought submarine programme I mentioned earlier. Now, whilst Dreadnought is many years from being in the water, Babcock, along with our partners BAE Systems and Rolls-Royce, are already seeking to move towards a future where the transition from design to hardware to operational use and sustainment, and the engineering assurance and acceptance processes associated with that journey, are embodied in a dynamic, integrated digital model and not in those digital filing cabinets I mentioned earlier. Future submarine support must move from its current reliance on past experience and opinion determining future actions to one with greater reliance on the facts and analysis shaping a needs-based, forward-looking plan of work that is more flexible to the changing operational needs of the Navy. As an alliance, we are making decisions now that will directly influence the planning and delivery of in-service support of Dreadnought. This includes enhancing our ability to understand the material state of the boat, predict failure events, plan maintenance and upgrade programs, deal better with unexpected major changes in customer needs and wants, and manage the supply chains and optimization of material inventories. If I cast your minds back for a moment to the asset lifecycle hexagons I shared earlier, we're looking at how the design of the boat enables better planning for the provision and maintenance of critical infrastructure, and also for the suitably qualified and experienced personnel that will be needed to support the boats throughout their operational lives. These objectives and many more have led to thousands of design recommendations to improve in-service supportability of Dreadnought many years before the boat enters service. Now, having given examples of how a digital thread and the use of digital twins can be used to drive predictive maintenance and inform engineering design decisions, I'll switch tack into looking at some interesting technologies that play a critical role in helping build and establish the digital thread. Many of the assets Babcock supports are not digital by design. We lack a complete digital thread for the assets and also often lack the necessary sensors to give us an accurate view of the material state of the asset, including parameters such as location, to operating conditions, to vibration modes and other indicators of asset degradation. I'm not going to pore over any individual technologies in detail, but there are a number of areas where we are investing in technologies and tools that allow us to establish a digital thread. At a group level, many of these technologies fall within our Internet of Things program, where we've been developing an end-to-end capability to ingest data into our secure enterprise IT systems. We've been also looking to establish common tool sets for ingesting, managing and visualizing smart devices, and building a common approach to accrediting those devices and integrating third-party applications and storing of data. For many in the commercial sectors, these objectives look relatively simple. And I might hear many of you say that cloud services such as Azure and Amazon AWS allow this to be done out of the box today. However, for Babcock, we operate in many highly regulated and sensitive environments, and utilizing some of these cloud-based technologies is not so straightforward. We must work closely with our customers and their accreditors to build tools and techniques that ensure the operational picture they establish is kept secure and only available to those who need the information to inform operational decision-making. Now, as part of this journey, we've built it up in stages and phases, as you can see on the page in front of you. First of all, we started out by developing our abilities to use LoRaWAN or long-range wide area networks technology to track and monitor assets. We've gradually extended that activity to include other sensors and bearers, and are now expanding into smart buildings and the use of IoT technology to optimize some of the critical infrastructure that supports the assets that we look after. Much of this ingest, data management and visualization can be done with relatively off-the-shelf technologies. But in many of the environments we serve, commercial off-the-shelf technologies do not exist, and we have to invest in developing novel sensors and approaches to capturing vital information. One example of that in the nuclear sector is Babcock's Cavendish nuclear business, where we're involved in the decommissioning of a range of nuclear sites. This includes design and build of complex equipment for Sellafield in Cumbria. It also, where we are looking at radiation levels inside some of the giant reprocessing plants at Sellafield, where those radiation levels are too high for workers to enter safely, even after its post-operational clean-out. In this example, the site's operator asked the industry for ideas as to how some of this hazardous, difficult work could be done remotely. And working alongside the wider Babcock organisation, Cavendish Nuclear searched for the combination of tools and technology capable of being integrated with its own proven nuclear products and deployed in areas of high radiation. The in-cell decommissioning system, or IDS for short, integrates components from different industries. The RAD-SCAN spatial and radiometric scanning system developed by Cavendish for remote mapping of contaminated plant, a virtual reality interface developed by Babcock International experts to process the data and enable operators to control the robot remotely, and a robotic snake arm with laser cutting tools that can be used to cut up the contaminated plant into small pieces for subsequent removal and storage, where we used a industry partner, OC Robotics. An exciting aspect of using 3D models and VR is the truly remote operability that they can enable. And I think this was something that was certainly touched on in one of the sessions yesterday. With today's IT infrastructure, there's no reason why the decommissioning team needs to be in the facility being decommissioned. Potentially, operators in other locations, perhaps on the same site, but even potentially globally, could be defining, downloading, and monitoring the operations of this system, and using that to manage in real time updates and interventions to how the system is being used. Now, very conscious of time, I will move on to a few closing remarks. So to conclude this keynote, management of critical and complex assets and maximising the associated value for our customers is at the heart of what Babcock does. Hopefully I've given you an appreciation of some of the digital technologies we are applying to meet the challenging and safety critical customer needs that we face. As I look at the examples, though, that I've shared with you today and some of the other ways I see technology being applied in new and novel ways to enable 3Life engineering services, there are a few observations that I feel are pertinent to the industrial and academic community we have here today. The examples I've shared and many others that I could have used to illustrate Babcock's approach to digitally enabled asset management are as a result of close collaboration with partners, including our customers, commercial partners, and academia. Close cooperation between industry and academia remains fundamental to realising the value that digital transformation of 3Life engineering services can bring to the owners of critical and complex assets. The days of waterfall development programs are rapidly giving way to more agile approaches, and the providers and users of technology need to be working more closely throughout the development lifecycle. To achieve this agility, it's important that we share a common vision of the key elements of the support phase of the asset lifecycle and drive coherence in research and development programs and projects. Sharing a common vision for technology development and implementation across academia and industry provides an opportunity to pool resources and investment towards prioritised areas of intervention and jointly invest both time and money to solving the challenges posed. A second key enabler of agility is continued work to establish common standards and architectures around concepts such as the digital thread and digital twins, and increase openness of access to engineering data from design intent to operational information generated by sensors and the assets operators and maintainers. Lastly, we develop, launch and operate our own as we develop, launch and operate our own technology programs, we need to ensure our people continue to have the appropriate skills and experience to unlock the benefits of the new technologies and approaches they enable. Hopefully some of you got a chance to join the session that was led by Neil Young and Michaela from Babcock yesterday. But hopefully if you didn't join, I'll recap a little, but digital skills, systems integration expertise are some of the skills that are growing in importance, and we need to ensure that we continue to actively invest in our people throughout their careers, and crucially to share that knowledge amongst peers. Academia has an important role to play across all of these areas, whether through early stage research, cooperation on developing standards through bodies such as the TES Council, or developing the TES workforce of tomorrow and helping upskill the people that we have today. Babcock works closely with Cranfield University's TES Centre and a number of other university partners in the UK and internationally. And I think we have many exciting years of work ahead if we are to fully realise the value that digital transformation can bring to 3Life engineering services. Thank you. Back over to you, John.
Thank you, Malcolm. That was a really insightful presentation.
I can't hear your audio, John.
Hello, can you hear me? Hello?
We can hear you. I can.
Oh, you can hear me? Okay. Malcolm, I'm not sure you can't hear me then. Maybe.
Malcolm,
Yeah, Malcolm can't hear us. Okay, he's maybe refreshing.
okay.
Good. The audience, could I ask you to add any questions or comments you have in the Q&A section of Remo, please? So we'll just wait for Malcolm to come back. Hi, Malcolm.
John, we've got a couple of questions.
Yeah. Malcolm, can you hear us now?
Hi, John. Yeah, sorry, I had to do a refresh of the application there. I think as I came off, couldn't hear you at all.
No, that's great. I can hear you very well. And we could hear you during the presentation. It was very clear. Thank you for. So there's a question from the audience. So Tom Sakao is asking, so there's a comment firstly. So he's saying, I can imagine the seamless digital thread is not easy to realize. What are the challenges concerning the coherency and consistency in the computer systems and models for product lifecycle management?
Really interesting question, and in part I would have to defer to some of my team in terms of the technical details that might sit around particular sort of PLM systems and such like. But I mean, if I was to look at it at the sort of the broad strategic level with industry, I mean, a lot of this comes down to having common standards for the data architectures and the way that we choose to sort of describe assets within these systems and the ontologies that we deploy. And then also critically at the point where information or data is handed from one system to another or one tool to another, making sure that those standards are open and that they are readily accessible is absolutely key. I think sometimes we have certainly in the defence environment seen closed standards or proprietary standards being used, which actually can have unforeseen consequences as you move into the support phase, because it can make it extremely challenging for the data, the information that's held in those systems to be shared readily with customers and with other partners in the supply chain.
That's great, thank you. And there's a follow-on question relating to what research would you recommend to academia?
Well, I mean, I didn't include a slide that I perhaps could have in this, John, which is actually some of the topics that we have ongoing with you guys at Cranfield. And I mean, I think the topics that we are pursuing with Cranfield, but also, as I sort of said, with Strathclyde, I think we're already tackling the ones that we're seeing as being the key issues for the 2 to 3 years probably ahead of us at the moment. But there needs to be a blend, I would say, of some of the fundamental research into, as I said before, sort of data models and ontologies and some of the challenges that we face around ensuring and maintaining data quality. But also there is absolutely a need for academic research to start to bridge that gap into practical application and the generation of value for industry and for the customers that we serve, and therefore making sure that sometimes academia can play a very strong role in helping us actually do the proof of concepts and the pilots to show how things such as augmented reality and AI can actually generate value in specific use cases.
That's great, thank you. And we have another question from Andrew Starr, which is, how do you bring the people along in the digital journey?
Great question, and I think I would partly do a throwback to Neil and Michaela's session yesterday, which I thought certainly delved into this question in a lot of detail. So hopefully, John, that's going to be available in the conference sessions, or certainly the proceedings at a later date. But I mean, if I was to sort of put it into my own words and sort of the focus that I put on this within Babcock, we need to show people the journey that we're going on. We need to set out a clear ambition and vision for what it really means to be able to deliver digitally enabled asset management and be able to help everyone within our organization, within Babcock, but also potentially further afield in our customers, in our supply chains, to understand the role that they play in realizing and enabling that vision as well. And I think if you can give that sense of purpose and direction to the transformation and the journey that we're on, then it allows people to sort of really understand the role that they are playing, and also how their own personal skills, capabilities, ways of working need to evolve and develop as we sort of face these increasingly digital or software intensive systems and assets. And I think if you get all of that in place, then a lot of what sits beneath that, I'd say, is fairly standard learning and development type activity. We then work very closely with our organisation and development community within Babcock to bring that into more tangible actions in terms of what does that mean for us to establish a digital skills academy, what are the courses and areas of learning that we need to be making available to our people. And also, I mean, critically, coming back to the relationship with Cranfield, also the relationship we have with Strathclyde and other university partners, academia then plays a very important role in that as well. And therefore, we've tried to develop increasingly close relationships with some key academic partners, because programs such as the 3 Life Engineering Sustainment Masters at Cranfield, but also some of the other courses that we partner with across other universities, become really important vehicles for delivering that training. And also, I do believe as we if we can achieve greater commonality in the type of training we deliver and the content we deliver to our people going forward, it will make it easier for people to sort of move around the organisation and share their skills and capabilities across some of the stovepipes that perhaps have existed in the past.
There's another question that I would like to ask is, you mentioned a number of technologies that you're looking into at the moment. Have you been considering how you can evaluate the productivity of these technologies? I'm not necessarily referring to the task. I'm also thinking of the technology itself. Is there a way to measure the productivity of the digital technologies?
Well, it's a great question, John, and it's one that is a complicated answer. But absolutely, if we ignore or fail to articulate the value that these technologies generate, then we are going to struggle to make room for the investment that's required. And I mean, I'll come back to productivity in a second, but if I talk about value, value takes many forms. It can be the revenue that's generated by a new technology and a new capability that provides. It could be cost savings that accrue within our operations. It could also be improvements in operational output and effectiveness or in safety. And all of those are sources of value. And the productivity of technology within Babcock, we try and sort of tie the value of our technologies to one or more of those areas. And to sort of come back to your point of productivity, we're always looking for, can we display a demonstrable improvement in one of those measures as a result of deploying the technology? Mm-hmm. sort of manufacturing or MRO environments, often that's quite a sort of, I'd say, relatively more straightforward to do, because you can look at your build lines, your repair lines, and you can show the insertion of a new technology, such as actually the LoRaWAN technology I mentioned earlier, potentially how it enables you to be more effective in the delivery of MRO. Probably where it gets harder is in some of the more sort of people-intensive activities, where sort of a lot of the work is not done in such a sort of well-structured or recognized system. And it's not so much that we probably can't measure the productivity improvement the technology generates, but often actually establishing the baseline for measuring that improvement in the first place does remain quite challenging and complex. And sometimes almost we can overdo it and want to measure the productivity improvement so precisely that we almost talk ourselves out of investing in new technologies. So one of the balances I try to drive is a sense of, as long as we can see enough productivity improvements that it justifies investment in an area of technology, let's not try and capture every single productivity improvement, because it might well get us into a reporting culture rather than a doing culture. And in this area, the key thing is making sure we continue to drive improvement, advancement, and application of new technologies, not sort of get ourselves into a bureaucratic mess, so to speak, of trying to quantify down to the last pound or pence the benefits they've driven.
Thanks, Malcolm. We have one last question from Keith Rushton, which is, what are the critical things being done differently to ensure digital transformation is successful? And yesterday we had a comment from Neil and Michaela that 84% of digital transformations fail. So what are the things that you're doing differently to ensure it's a success?
Very interesting, John. And I mean, I always find it interesting when the McKinsey stats are rolled out, because as I may have included in my bio for this conference, I spent a couple of years there between Rolls-Royce and Babcock. So certainly I know the value of using a number like that to to illustrate an issue. And I think it can be a powerful call to arms to say we absolutely have to address that issue, whether it's exactly that number or different. It probably open to debate. But I think one of the reasons, and if I look at this actually at the maybe at the enterprise level, within defence, one of the major reasons for failure is that in the past has been each individual company or stakeholder has tried to embark on this transformation on their own, or not necessarily with the full sort of support of the wider enterprise. I think one of the things that really has changed over the last 2 to 3 years in the defence sector, and Team Defence Information, which Babcock is a part of, has been critical in this, is convening a much greater level of convening those cross-industry forums around some of these key topics. And a number of my team are involved in working groups where the focus is, how do we establish that common approach to digital twins? How do we make sure that we have common and scalable, reusable data architectures underpinning this? And the intent of that work is that hopefully within defence, but certainly I think applicable to many other sectors as well, if we can establish those common principles and see them sort of being widely used and adopted across industry, it will create a much better environment for digital transformation. Otherwise, I think, as I said earlier, we might, if we see a proliferation or sort of continued development of proprietary standards and proprietary systems and technologies, digital transformation, I think, will stumble, because it's so reliant on having those sort of common underlying sort of data systems and architectures. And again, in the Ministry of Defence parlance, the digital backbone that the UK Ministry of Defence is trying to establish is absolutely key to this.
Great, thank you, Malcolm. I'm conscious of time. We're going to continue with the next keynote. I think this was a really fantastic way to start the second day of our conference. So thank you, Malcolm.
Thank you very much for having me, John. I look forward to the rest of the day.
Thank you. So we're now moving on to our second keynote of the day, which is with Professor Andy Nealy. So Andy, welcome to the stage. I'm just going to give a quick intro through your bio. So Professor Andy Nealy is the Pro Vice Chancellor for Enterprise and Business Relations at the University of Cambridge. He's head of the Institute for Manufacturing and head of the Manufacturing and Management Division of Cambridge University Engineering Department. So with that, Andy, we're looking forward to your keynote speech. Thank you.
Thanks, John, and good morning, everybody. First of all, congratulations on putting on such a great conference. We live in these slightly strange times, made even more strange by overnight results from the US. But it's good that we can still have these kind of events and conversations. And to the audience as well, thanks for spending some time with me this morning. I'm not planning to do death by PowerPoint this morning, so I'm just going to talk, and I want to talk about three different things. So the first thing I was going to do is just reflect a little bit on what we've learned about the servitization of manufacturing through life engineering services and so on, through the work of an initiative called the Cambridge Service Alliance that I was involved in helping set up and run for a while at the university. And that is now run very successfully by my colleague, Mohammed Zaki. So talk a little bit about what we've learned through the Cambridge Service Alliance about servitization. Then I thought I'd talk a little bit about some of the national and international features of the landscape that we're currently living in and are likely to be living in for a little while. And then I wanted to return to the things we'd learned about servitization and say, well, actually, what do we need to think about next in light of what's going on in the international and national landscape that we currently live in? And I hope that that will give some thoughts for people in terms of interesting questions to ask if you're a researcher or from a business perspective, things that organizations need to think about. So let me start with what we've learned about servitization. Just a quick history here. The Cambridge Service Alliance was set up by the Institute of Manufacturing, BAE Systems and IBM about a decade ago. And it was really focusing on looking at the sort of growth in service-based business models. So if you take an organization like BAE, at that point in time, over half of its revenue comes from service and support activities. And yet virtually none of its R&D spend went into looking at service and support. And that was partly why BAE Systems and indeed others got so interested in the question of actually how do we think about services and servitization and the evolution of business models in different sectors. IBM got involved because they observed they've both gone through that transition. They'd effectively reinvented the business as much more of a solutions type business, but also they saw that same trend happening in lots and lots of their customers. And so when you think particularly about asset heavy industries, there were lots of firms thinking about how do they reinvent the business model, how do they make the shift from product to service, a lot of discussion about shifting from outputs to outcomes, a lot of discussion about the way that as you went to outcome-based business models, you end up in much longer term relationships with your customers. A lot of discussion about how you pool capabilities across supply chains and effectively build ecosystems. And so lots of organizations thinking about how do we make this transition and how do we make it successfully while we're still running the asset heavy, the product based business. And that was really the sort of focus of the Service Alliance. We developed various frameworks, but one of the ones that I thought has really stood the test of time, and it is the one I want to sort of use to frame today's presentation, consisted of 4 components. So one of the early studies we did was when it looked at about a dozen businesses from different sectors that had made the shift to services, people in the rail sector, in the utilities sector, defense and so on, and just said, you know, what's actually happened in these organizations as they've tried to make this transformation to services. And there were 4 key lessons that came from that. So the first was a really strong focus on outcomes, and understanding in depth what the outcome is that your customer, and in some cases what your customer's customer is really looking for, and thinking about, you know, how do we as a business not only help our customers do a good job, but help the customer's customer do a good job. There's a very famous quote in the marketing area, a guy called Theodore Levitt, who was a professor at Harvard, used to talk about customers not wanting quarter-inch drills, but instead wanting quarter-inch holes. And actually what we observed was that wasn't really right. What these firms were doing was they were thinking about why do customers want the hole in the wall? And if you understand that, you can then start to think differently about how you might deliver the outcome they want. So if you take I put a hole in the wall because I want to hang a picture. Well, actually, I don't really necessarily want the hole. I want the ability to get the picture on the wall. And there are lots of ways I could do that. I could get a picture on the wall by painting it on the wall. I could get a picture on the wall by getting a data projector and displaying it on the wall. I could get a hologram that was next to the wall. There's all sorts of ways I could offer that service. And so what we saw was when people thought and really dug into the outcome the customer was wanting, or the customer's customer was wanting, they started to reframe the business model, and they started to think differently about what it was their organization was really trying to deliver. And I think that reframing of the boundaries of the business becomes really important. In the healthcare sector, you get into conversations about actually, patients don't, if you're an AstraZeneca or a GSK, they don't necessarily want the drugs and the tablets. They don't want to be ill in the first place. So what could we do to actually provide healthcare services that prevent disease rather than treating the disease when it comes down? We're not going to stop all disease, clearly, but what can we do differently to prevent disease? Clearly, in the context we're living today, COVID, there's an enormous amount of discussion about how do we prevent transmission of COVID, and that's a topic that many of us worry about. So that was the first thing, that one of outcomes. The second one was about the value delivery system. And really what people were thinking about here was you have to explore really carefully, how do we pool capability across different sets of organizations to build a value delivery system that actually allows you to deliver the outcomes your customer's customer wants. So a tangible example, one of the firms we worked with a lot was Caterpillar. And Caterpillar for years have done work around putting sensors on machines. They've done the asset management stuff. They've been remotely monitoring activities. But one of the things they started to think about, and with some of their customers, was if you take a quarry, how do we optimize production at the quarry? The outcome the customer wants is the ability to extract minerals from the quarry as efficiently as possible. And so can we use the data that comes back off the machines to start to monitor what's going on in the operations of the quarry? And if we can do that, can we then help the customer achieve the more efficient extraction of minerals? So tangible example, if you take the blast pattern at a rock face, if you know how long it takes you to fill a truck, and it takes you, let's say, 98 seconds in one quarry and 90 in another, you'd start to say, well, hang on, what's the 8-second difference? And the cycle time really matters in these operations. They're very high speed. You might go and look at the rock in the quarry that takes slightly longer, and you find that actually the shape of the rock that the digger's having to pick up is slightly the wrong shape. So when you're picking up rock, you don't want it to be sand, and you don't want it to be an enormous piece of rock, because there's an optimum size where when you put your spade in or the shovel in on the digger, you pick up the maximum amount of material in that single shovel. If the rock's too big, it's a bit like filling a bucket with stones. You don't want them all too big because you get loads of air gaps. So what creates different sizes and shape of rock? Well, that's the dynamite blast pattern. So you can start to explore from the data that's coming off the machines that actually there's a problem with how we're putting the dynamite in the rock face to blast out the rock, and that's what's causing the slowdown in loading of trucks. For example, Caterpillar doesn't have all of that capability. So they ended up partnering with a business called Uptake, which was a data analytics company, to do some of the analysis of the Caterpillar data. They're partnering with the Quarry to access some of the data in the quarries. They're partnering with the people making the explosives to understand dynamite blast patterns. And it's a wide range of capabilities that you have to put together to build that value delivery system that really delivers the outcome the customer wanted. So that was the second sort of theme. The third theme was this notion of accountability spread. And the idea here was saying, if you take more responsibility as an organization for outcomes, so you say, look, we won't just sell you a digger, a truck, we will actually help you optimize production of your quarry in the CAT case. And you then pool your resources and capabilities and therefore become dependent on other organizations to help you deliver that capability. You've taken on more responsibility, but effectively you've reduced your direct control over the value delivery system. And so you increase the risk, and we call that the accountability spread. I'm accountable for more, but I've got less direct control over the way that those outcomes are delivered. And that creates all sorts of risk for the organization providing the service. You couple that with requiring customers to do their bit. So there's a customer dependency. If I'm giving advice back to quarries to say, this is how you optimize production at your quarry, if the quarry doesn't act on that advice, I never deliver the outcome I'm contracted to deliver. So I become more dependent on other organizations. And that's really this notion of accountability spread. And of course, all of this is taking place in an ecosystem. So what we see increasingly is that competition runs at the level of the ecosystem as well as the individual firms inside it. And there are lots and lots of examples of that. One of the most topical ones at the moment is Nvidia's takeover of ARM. So for years, ARM has positioned itself as effectively a neutral vendor of IP, and it's provided a platform. It's willing for anybody in the telecoms industry to use its IP, and because it's a neutral vendor of that IP, all the different competitors have come in and said, yeah, we'll use ARM technologies in terms of our chips, and so, etc. Nvidia is a significant customer of ARM. By Nvidia taking over ARM, it's going to set up a dynamic in that ecosystem where people are going to start to say, hang on a minute, if ARM comes up with some really new, great IP, how do we know that ARM is going to allow that to go to everybody in the ecosystem? Or is Nvidia going to capture it and use it initially to push themselves forward and only later allow it to leak out to the wider ecosystem? And so you end up with some really quite complex dynamics around how ecosystems work, particularly in these sort of outcome-based business models. There's lots of other lessons that we learn over the years, but if I just focus on those four, so that notion of outcomes, the value delivery system, accountability spread, and ecosystems. And then bear these in mind as I shift to the sort of second topic and think about the current national and international landscape. And there are three themes here I want to pick up. So the first is the whole question of digitalization and data. We've just been talking about the importance of digitalization. The second is around resilience, and particularly resilience in light of economic and health shocks. I include COVID in that category. You know, we're living in this really quite strange time where we're suddenly learning about the impact of a global health pandemic that we knew might happen at some stage, but we as individuals weren't necessarily expecting it, and certainly weren't planning to live like this for quite the extended period we have, but that is where we are. And then the third one, I think, is to think about the next or a future major economic shock, which is all around the question of climate change and the energy transition. So let me start with data and digitalization. Just think about how that changes, what's happening now, how that changes some of the lessons we've learned about servitization over the years. So, I mean, clearly at one level, and we've just been hearing this, data or digitalization, and then the data that gets created as a consequence of digitalization is a fundamental enabler of servitization. The Caterpillar example I gave, one of the reasons that Caterpillar is able to innovate its business model and say, we will help you optimize production at the quarry, is because of the data that comes back off the machine. So we know how long it takes to fill the truck because the scales in the bed of the truck monitor the point at which the first bit of load goes into the maximum amount of load. You know, therefore, how long it takes. You can harvest that time, and that's a useful input into getting insight into what's happening in the quarry. As you're driving up the haul road, the data that comes back from the suspension system shows you where there are potholes in the haul road because the suspension starts to bounce. If the driver accelerates too much as they come out of a pothole, you'll see that impact on acceleration. That will also impact fuel burn, and minimizing fuel burn is one of the ways of optimizing production at the quarry. And so all of that data is what gives you the insight into what's happening. The data is not only useful to Caterpillar. So originally, you know, it used to be the asset manufacturer went, well, I'll put the sensors on, I could then remotely monitor the condition of the asset, I'll get useful data back, which will allow me to make better maintenance plans. It's also, as we saw in the example of the quarry, useful to the quarry operator because it allows them to start to do things differently. The data allows you to better manage accountability spread, I would argue. So if you know the wear and tear on your equipment, if you can monitor the engine revs, take a car hire firm. You know, in the past, what used to happen when you rented out cars, so cars as a service, people would pick them up, they'd drive them off, you'd get the mileage at the point they left, the mileage at the point they came back, and that was pretty much all you knew about them. You didn't know whether they drove them into the ground, whether they were braking excessively hard. You didn't know the torque that was being exerted on the engine, etc. All of that data you can now stream back, and if you keep that data over the life of the asset, you have a better understanding of the quality of the assets, which you could then price into, for example, the residual value of a hire car at the end of its life as a rental car. So suddenly the data that's coming back allows you to better get a grip on the accountability spread that you've taken off as you as you offer some of these outcome-based models. So data is clearly valuable. But for me, an interesting question, and in many ways an under-researched question, is how do we value the data? So I know it's valuable, I know data is an asset, but how do I understand, how do I put a value on data itself? And why does that matter? Well, it seems to me that if you could get a much better handle on data and the value of data, you can start to change the nature of conversations in organizations about this. So I was involved recently in a project in Highways England where we were asking exactly this question. So Highways England, basically, they provide and maintain the UK's major road network, so all the motorways, all of that sort of stuff. They've got a vast network of physical assets. You would imagine in an organisation like that with a big network of physical assets, they worry about the quality of the road, they worry about scheduling when they're going to do repair works, do they need to put an extra lane on the A14, or what are they going to do to the M25 next, etc. So there's a real focus on the physical assets inside the organisation. But they also have access to masses of data about how that network is used. So as mobile phones travel along roads in cars, they are in turn, the mobile phones, streaming data back about the speed of the traffic, because you know how fast the phones are moving, they're sitting inside the cars, therefore you can work out how fast the cars are moving. That's really valuable in terms of understanding traffic flows, as an illustration. And so the question that you end up asking in Highways England is, what's the relative value between the physical assets and the data? If I could understand that, I could start to have much more sensible conversations about, is it worth investing another 100 million or 2 billion or 10 billion in building a bit more road, or would I be better investing 50 million in improving the quality of that data asset? Because if I had better data on traffic flows along the road, I might not need to build an extra lane on the motorway, because I can advise drivers on when they should be using the road to manage the traffic flows. So maybe the data, the investment in improving the data would give a better return than the investment on the physical assets. So the way that we looked at this in the Highways England context was we thought about not lots of people talk about data pools, but we said actually it's much better to think about data lakes. Think about the individual data sets that together make up the data pool. Clearly, you sometimes want to combine those individual data lakes because joining up the data sets is valuable. But those different data sets actually create value for each of the key stakeholders in the organization. So take a road haulier. For a road haulier, knowing when traffic roadworks are happening, so the predictability of our roadworks, or knowing when traffic jams are occurring and therefore they can reschedule or reroute their deliveries, becomes really crucial. And you can start to compute, well, actually, if I could avoid delaying the Tesco distribution network by 5% and make sure delivery's on time, what would be the economic value of that to Tesco in terms of avoiding stockouts in stores, etc., etc. So you can start to put a value on the data by thinking about what value the data allows the key stakeholders to create. And in doing that, in Highways England's case, we came to a very robust methodology for doing this. But basically, the end result was that we said, well, the estimation is that the Highways England data is worth about 1/4 of the physical asset value that Highways England has, so the road network. Why does that matter? Well, suddenly what you then start to do inside the organization is you change the nature of the conversation in the business. So the executive team started to say, well, hang on, if our data is worth 1/4 of our physical asset value, then we should be spending 3 hours talking about roads or the physical assets and an hour talking about data and the data assets. Have we got that balance right? Do we spend enough time thinking about the data assets, or do we spend too much time thinking about the physical assets? And if we haven't got the balance right, what do we want to change? If we understand in our individual data lakes which ones create most value for the stakeholders, we can start then to work out where we should invest in the future to improve the quality and underlying data. And so I think that whole question of thinking about data and understanding the value of data can change the language and the conversation that goes around that servitization discussion. And so for me, for the theme around digitalization of data, the key challenge I'd sort of throw out there is actually developing better and better methods for valuing data so we can really understand its potential and its worth when delivering services. And the Highways England example is a really good illustration of how you might go about valuing data. Second theme, resilience. Why resilience? Well, clearly we're living in a world where we're learning rapidly about the impact of unexpected shocks to organisations. If you look at the National Risk Register for the UK, pandemic was in there. But actually, I don't know many organisations that had pandemic on their risk register when they were looking at the risk register at the board. And yet you can bet now, in fact, I've got a board meeting later today, where COVID is the #1 item on our risk register at the moment. So we're having to learn how to cope with these unexpected shocks, and clearly resilience of the organisation becomes crucial there. I think the challenge there for the servitization world is that if you've adopted an outcome-based business model, and if you've gone into that world of saying that we are going to provide the outcomes that our customers value, then in a world where suddenly the rules change, your business model gets significantly impacted. So take the classic, Rolls-Royce for years has talked about selling thrust rather than selling the engines, or in Caterpillar's case, if you guarantee to minimise the cost of per tonne of material extracted from the quarry, and then your customers are forced to lock down. So the airlines can't fly, and yet your business model is predicated on the fact that you're selling thrust to the airlines. If they're not flying, they're not using thrust, therefore your market suddenly completely disappeared. And you can see the stress in the aerospace sector, not just around that, sort of around spares and repairs of engines. But what we have to think about is there may be situations where actually the outcome you promised to deliver is either no longer of value to your customers, or you're not able to deliver it. And so where does that leave your business when you're locked into a contract that you actually cannot deliver? And I think the pandemic, the COVID pandemic, forces us to ask that question and to say, well, have we really thought carefully enough about building resilience into the businesses and the associated business models so that we can pivot the value delivery system and still provide outcomes people want when the world around us changes? So a super example of this is the way that pubs and restaurants have responded. If you think about the entrepreneurially minded pubs and restaurants, very quickly they pivoted to become takeaways. And they said, we'll stay open, we've still got kitchens, we can still provide food, people still want food, they don't always want to cook at home, they may not be able to come and sit in the pub, but we can reinvent our business very quickly to become the takeaway, or the local breweries doing takeaway services around beer, etc. So education establishments, you think about how quickly the universities pivoted to adopt and rapidly scale technologies around delivering online learning. Now, we were forced to do that to an extent, We couldn't have the students in the classroom for a while. We are in the next wave of the lockdown in the UK. Universities are remaining open and will continue with some face-to-face in-person teaching when it's sensible. But it's fundamentally changed the business models of some universities, and it's resilience that actually allows you to adapt to those changing circumstances. And so I think in the servitization literature, when I look at it, I don't hear or didn't hear a lot of discussion about how do you build resilient business models for service-based businesses or for through-life engineering services. And I think we'll have to think a lot more about that in the future. And of course, shocks will continue to come. So the third theme, the notion of climate change and sustainability. I mean, we all know the data. It's clear when you look at the carbon budget for the world, it is running out. We are releasing too much CO2. There are challenges around how we meet the Paris targets and so on. Lots of firms are starting to announce net zero targets, or in fact, in some cases, reversing emissions. So Microsoft's made some announcements around that not long ago. It's interesting to see how the oil majors are responding to this, because if you think about the oil majors, the Exxons and Shells and BPs of the world, of course, their whole business model has been around extracting carbon from the earth through fuel and so on, and then we use it in our cars, we use it in planes, we use it in all sorts of manufacturing processes. But fundamentally, if the world shifts away from or shifts towards a zero carbon future, what does that mean for the oil businesses? And they're setting emissions targets. They're innovating their business models. Really interesting example at the moment for me is BP. So BP publicly declared that they want to shift from being an international oil company to an integrated energy company, from an IOC to an IEC. They've committed to, for example, reduce the levels of oil production by about 40% by 2030. So they're deliberately saying we're going to shrink the core of the business around oil production. But the notion behind the integrated energy company is they're saying, well, actually, the outcome that our customers want is clean, reliable, and affordable energy. And lots of our customers are making the commitment to having clean energy. So they don't mind where the clean energy comes from. They don't mind whether it's wind or solar, but they do know that they need to shift away from coal and oil. So how about BP as an integrated energy company offering a service where it says to other firms, we will help you decarbonize. We'll help you adopt a cleaner and more energy efficient model for your operations. We'll help you take carbon out of your operations. And in fact, they could go as far as many of the traditional sort of servitized businesses have gone of offering outcome-based contracts. They could say, we'll provide your energy, we'll help you decarbonize. We'll use our trading power. BP is one of the largest trading businesses in the world to hedge future energy for you on those renewable or clean energy sources. In doing so, we'll reduce the cost of your energy as well as making it cleaner. And we'll do all of this as a service. So we'll have a gain share mechanism in place where we manage to make the energy cleaner, cheaper, and more reliable. And the more we do that, we will benefit through the gain share mechanism. And so you end up aligning the incentives between the integrated energy company and the firm that is then using its services. And if you go back to the original discussions about servitization, a lot of that was about aligning incentives. It was about getting the provider of the assets not just to go, here's the assets, it's your problem now, but to get the provider of the asset to say, no, I want to work with you to make sure that you can use the asset in a way to achieve the outcome you actually want. That same transformation you can imagine happening in the oil and gas sector around energy as a service in the future. And I think that's really interesting because it's actually the power of digitalization and data coupled with the emergence of the economic shocks that we are both seeing and will see that are forcing firms to continue to rethink their business models and to look for resilience in those models. And I think as those trends continue to play out, we'll see more and more sectors picking up on this notion of servitization and saying, actually, there may be something in this for our sector. So the old challenges will remain. We'll need to deeply understand outcomes. We'll need to deeply understand what the customer wants. We'll need to think about the value delivery systems, what we do and what we ask others to do and how we pool our capability. We'll need to understand accountability spread and the risks that go with that, particularly in the light of business shocks. And we'll need to think about how we reconfigure those ecosystems to change some long-held beliefs about how we approach businesses. But as we do that, we're going to have to think about questions of value of data. We're going to have to think about questions of building resilience, and we're going to have to think about things like the energy transition. How do we change the alignment of incentives so we change some of the business models that people operate? So I hope that some of the things we've learned about servitization both hold true, but can also be applied to some of the challenges the world is facing today. So let me stop at that point. I'm very happy to take some questions. Thank you.
Thank you very much, Andy. This was a great keynote speech. There are a number of questions. I'd just like to kick this off. First question is, often servitization for many companies doesn't work successfully. And there's some publications, and I know you've published as well. Could you go into a bit of detail as to why the servitization, why does it not work in some cases?
Well, I mean, I think that's absolutely right. So people may know I did some work on bankruptcy and links to servitization for some of the firms that are trying to make that change. I think I would say there's sort of three things here. So the first thing is actually the cultural change that needs to take place. If you think about, I mean, this is why the Highways England example is actually quite interesting. Highways England have traditionally been an organisation that have worried a lot about physical assets, the roads, the network they've got. And when you start to say, actually, the world in the future is more about the data and how that allows you to better manage the assets and provide the service that your customers want by using your assets, people go, yeah, but actually what really matters is the road. I mean, it's the same. We used to joke with Caterpillar that if you cut someone from Caterpillar in half, they would bleed yellow because they love the big yellow truck. But actually, the big yellow truck was not really the thing that mattered ultimately to the customer's customer. So changing the culture away from just focusing on the technology to saying we really care about the services, I think is one thing that a lot of firms underestimated. The second thing I would say is that question of accountability, spread and risk. So I think too often people didn't think carefully enough about the risks that they were taking on when they moved towards outcome-based contracts and the control they were losing over the value delivery system as they started to partner with others. And so because they didn't think about that, they actually ended up finding they took on contracts where they were exposed to a lot more risk than they'd expected. And they had no way of dealing with that risk. And so there are some examples of horror stories where people are taking on service contracts where they haven't thought about that carefully. There's a challenge I think will face the energy companies. So the BP example, you know, it's all very well saying we might offer outcomes where we help our large corporate customers get cleaner, more reliable, more affordable energy. But part of that is going to require the corporate customers to change the way they behave. And if BP doesn't have a way of managing the behavior changes in those corporate customers, they could end up not delivering on their part of the bargain. I think people underestimate that piece. And then the third thing I would say is one of, actually in some cases, the customers are not ready. So there are some great examples where individual firms have come up with really good innovations and services that you go, this absolutely makes sense. And yet it's been impossible to get the customer to move with them. And so you get this mismatch. And so I think that one of the things we did observe a lot was the need to make sure you chose mature customers. When you were thinking about offering services, what you really wanted was sort of benevolent but demanding, forward-thinking customers who would help pull you along as an organization and allow you to test out some ideas. And you need to make sure your customers are ready to make some of the changes in tandem with you. And if you don't get that right, you can end up investing a lot in things that just don't work in the market.
Great, thank you, Andy. There's another question from Andrew Starr, which is value necessarily a pound money sort of value, or should we consider wider societal sustainability benefits? And if
Yeah. Yeah. So that's a great question, Andrew. I mean, I think absolutely, you don't just need to think about value in terms of the pounds. The way that we handle this in the Highways England example was we were talking explicitly about the value that different stakeholders wanted, but then trying to convert it into an economic value. And the reason for converting into an economic value was because that made it much easier to have the conversation inside the business with colleagues from finance and so on, where they understood that language. And so you would start with a conversation, you know, the consumers, the commuters, when you were talking to them, one of the things they cared about was limited emissions. You know, you don't want to drive around on smoggy roads and so on. But starting to put some sense of value on that, I think allows you to just have a more refined conversation inside the organization. If you make it if you leave it too intangible, I mean, this is one of the problems previously with data. People always said, well, yeah, clearly data matters, but we don't really know how much data matters. And so finding a way of converting into a financial value, I think allows you just to have a comparative conversation about other assets, but you have to, in imputing that financial value, absolutely take the broader perspective and say it's not just about a bit of data is worth £3.50 because I can sell it on, you know, sell it at Data Mart for £3.50. It's a much broader conversation than that and thinking about the valuation.
The related question from Miriam Farley, which is about servitizing requires data sharing among stakeholders. So how do you convince the stakeholders in terms of the value of collecting that data?
Well, so I mean, I think this is one of the big challenges in the ecosystems, and particularly it's about the infrastructure actually to then allow you to collect the data. I think I'll separate two questions. There's a infrastructure to collect the data and then the sharing of the data itself. So on the infrastructure piece, if I go back to the Quarry example, you know, most quarries are mixed fleet quarries. So you'll maybe have 30% Caterpillar equipment, 30% Volvo, and 40% Komatsu or something like that. What you really want is a single data infrastructure that allows you to harvest data on the quarry as a whole. Now, on the individual machines, the manufacturers may put the sensors on there, but you also want some sensors around the quarry. The problem is that the individual manufacturers don't, if they installed any equipment, they wouldn't necessarily want to install it and then allow the other manufacturers to access that data because they're competitors in the marketplace. And that's also the problem with them sharing the data. And in some cases, in more complex ecosystems, you take the rail network, the question of who should digitalize elements of the rail network, should it be the train companies, should it be the government, should it be rail track because they own the track itself? You end up in this endless debate about who's going to make the investment in putting the infrastructure in place to allow you to capture the data when all the different parties potentially benefit from the data, but it may be some time down the track before you can actually start to benefit. So there's quite a big upfront investment. And so the first challenge I think you face is one of making the business case clear enough about how people will benefit from the data in due course once the infrastructure investment's been made. And in some cases, I think government has to step in. On large public assets, government has to step in and build some of that infrastructure. So energy charging systems, we will have that issue in the UK for electric vehicles. Then there's a separate question, even if you got the infrastructure in place, if depending on who owns or who harvests that data, what the protocols are for sharing the data and what the agreements are. And clearly, if you've got the mixed fleet model in a quarry, you're really going to struggle to get Volvo and Komatsu and Caterpillar to share data about their machines unless you build that into the contract in some way. And the only person or the only organization that can do that is the customer. So in terms of setting up some of these agreements, thinking really carefully about what you want to do with the data and how you want to share it at the outset becomes crucial. The alternative approach, if you are in a bind and you can't get the contracts changed, a number of quarries have done this, is you end up going to a single provider and you say, well, look, if you're going to work with us, and this is part of CAT's business model, if you're going to work with us to help optimize the quarry, we won't buy the equipment from you. We'll use your equipment on the quarry. We'll pay for the costs. We'll pay a fixed price per ton of mineral that's extracted. We won't bother having Volvo and Komatsu on here at all. We'll just have a much more integrated system, and then you don't have such a problem around the sharing of the data. But again, that's a transition that people have got to take. But they're really incentivizing sharing of data across competitors. If you start from the position of each competitor owns their own data and there's no contractual obligation to share it, and there are no incentive mechanisms in place, then you can absolutely see why people hold on to their data. So you have to address those underlying causes.
Final question, really interesting. I don't want to skip it. This is from Steve Wilding at Babcock. So the question is, where support contracts have to be competed, do you believe customers are able to write statements of requirements that allow for innovation?
That is a really good question. I mean, I think there's a really interesting piece in here, and to a certain extent, it links back to the first question as well. I mean, I think there's an incentive often for the people bidding for the support contracts to overstate what they can do, because it's a competitive process, and so you have to make strong claims about what your capabilities are and what you can actually deliver. I think there's often a knowledge in the customer that is commissioning the work that they know that you can't do all you're promising to do when you bid for the work, but there's almost a collusion. People pretend they don't know that, so you end up with this slightly strange artificial situation where people claim they'll be able to deliver one level of performance which will require all sorts of innovation, knowing that they're not entirely sure how to do it. The customer knows that they don't know how to do it, but they equally don't want to say they don't know how to do it, so you end up then getting into contracts which are really difficult to deliver. I think the mature contracts, and this is why the long-term relationships really matter. If you have yes, the contracts have to be competed, but if you have a mature relationship with somebody and you are looking at I mean, some of these contracts are 15, 20 years, you can build over a period of time, ramping up innovation in a way that, as the trust builds up, that allows you to get more progress on jointly jointly developing solutions. We wrote a report a while ago called Innovating in Reverse, which was basically saying that you should, in service contracts, think about the first contract a bit like R&D spend. So don't look at the first contract as a normal profitable contract. Think of it as an investment in building your capability to deliver the service in the future. And then the way that you make your money is by replicating that service in other areas. Whereas in the classic product world, you invest a load of money in the product through R&D, and then you launch it to the market. So if you thought about the investment in the innovation stage of the service contract, and you could effectively zero cost basis or a zero margin basis, agree that with the customer, you could come up with really interesting innovation, but you think of it through the R&D lens rather than the straightforward commercial contract.
That's really helpful. Thank you. So with that, I'd like to close this session. Andy, this was really insightful, very, very informative. Thank you very much for your keynote. With this, we're now going to go and have a break. Gustavo, would you like to add any final comments?
We will be back at
Andy,
10.
thanks a lot.
Thank you, Andy. Yeah, a really interesting talk. So just my announcement is that we're going to be back at 10:45 with one workshop and 2 parallel sessions with different papers. So let's see you in 20 minutes.
Great.
Thank you very much. Thank you.
Thank you all. Just to announce, we will be taking you back to the floor to allow you to start conversing with the new table. Please feel free to move across tables to have your networking details. We will reconvene in the respective sessions at 10:45. Chairs and speakers to the respective rooms, please.